So welcome back for the third lecture of the first week. We had been studying essentially interest rates. Today we are going to talk about term structure of interest rates. So what is meant by term structure? Term structure means that the behavior of interest rate over a given period of time, that is for various levels of maturity dates, how would the interest rate behaves. It has been often seen in the market that if you take a bond and hold it for 10 years, and if you take a bond and hold it for 2 years, the bond which you hold for 10 years gives you substantially more interest rate than compared to the bond that you hold for 2 years. So this idea, this fundamental fact that if you hold money for a longer period, you get more interest rate, is the fundamental idea behind term structure. So for example, if you take a fixed deposit for 30 years, you get a higher rate of interest, or 10 years for example, you get a higher rate of interest than you hold a fixed deposit for 3 years. For example, you go to State Bank of India, hold a fixed deposit for 3 years, you have a lower rate of interest compared to if you hold for 10 years. For 10 years the money almost doubles. So that has been the fundamental idea, that if you hold money for a longer duration or invest money, you get more interest rate or yield. I of course assure you that this is our last discussion on interest rates, because and you might be wondering why we need to discuss so much about a simple notion like interest rates. The idea is that interest rate is the most fundamental notion in a financial market, and that is we are studying it. Okay, so interest rate is a fundamental notion, and whatever you do, whatever computations you do for various financial instruments, when you want to compute their price, the interest rate play a very fundamental role. So here today we are going to talk about two types of interest rate structures, that is two types of. Now we are going to talk about two types of rates. One is called the spot rate and another is called the forward rate. Now let me first talk about spot rate and what does it mean. Spot rate is the interest quote that you get immediately the moment you want to buy a bond, and spot rates are usually evaluated by looking at zero coupon bonds, and especially government treasury bonds, government bonds which are surely non-defaultable. So the interest rate that you get on zero coupon bonds, usually banks quote it yearly, is called the spot rate. And that is called the spot rate. So in the term structure theory, the spot rate is a very basic concept. So that is the basic interest rate that you should have in a market. So what is a spot rate? So you come with some amount of money to buy a bond, So you have come with say some k rupees to buy a bond from me, then the interest rate quoted is the spot rate. Now, how do I compute spot rates? That's very important. So basically at t equal to time t equal to 0, invest the money, and at time say t, you want to take back what you have invested in the bond with the interest. So at t equal to 0, you can quote a spot rate ST, S0, and at time t equal to t, you will be essentially getting back money dependent on that interest rate. So let us just look at the yearly quote. So if I invest $1 or say $8 or rupees I have invested, so dollars are very common when it's written in most books. So if rupees I have invested now with a spot rate S1, yearly spot rate S1. So for 1 year my spot rate is S1. Then at the end of 1 year I obviously get, this is exactly what you get. But now suppose I have invested money for 2 years, then I quote a spot rate for 2 years, not for 1 year. At the very beginning I quote a spot rate for 2 years, which I call S2, and then the money I get by standard compounding. So you already know how to compute these things. So this is very important. So under the convention of quoting yearly spot rates, so at time t, so my money grows to now it is very important that t has to be an integer. If t is a fraction, then some adjustment has to be made, because that is what exactly what banks would do, or even any money anywhere where you put your money they will do, because otherwise it is very difficult to make such computations. So t has to be an integer. You can do the compounding by dividing the whole year into m periods. So see, if you look at the spot rate for the second year, if I invest for 2 years, then even for the first year I am getting interest rate that is charged for the second year, for holding for 2 years. Not that I get it first for the first one, S1 for the first one, and second S2 for the second one. It is not that. So you quote, so because these quotes, this S1 or S2, they are all quoted at time t equal to 0. Now if you want that whole period, you want to keep your money, hold your money till time t, but you want to have the every year to be divided into m equal periods, then the money that you will get if you invest a rupees. Now it is very important, banks can also continuously compound, and ST here. So you know, even if I am using the same code that I got for the tth one at every stage. So here also it is to be very important that MT must be an integer, or some adjustment has to be made. Okay, so this is what you get. Of course, you can continuously compound and take the limit as m tends to infinity. So, as m tends to infinity, my spot rate, this would become e to the power STT, right. So, ST is my given thing, it will become e to the power ST, T is the spot rate for every time t, and that into A. So, this is the money that I will get back. So, this is money compounding. So, once you have a structure of how do you would actually, how much money you would actually give me, you can actually find what worth, how much money I should pay now to you if you are selling me the bond, so that you give me the money, this amount of money at the end. So, that is what is called discounting or present value or present worth of that instrument, which we had already been studying for quite some time, but I would just recall so that you recall again all the things that we have studied and we get there. So, you must be observing that the math is very simple, but as you go on, this is just the first week. So, you will see from tomorrow the math would slightly take on some level. Okay, so let me first start talking about the discounting factors associated with this, which you can easily figure out, right, but still let me write down. So, now we will write down the discounting factors. So, of course, we are only making one yearly quote. So, the discounting factor for the kth year is the discounting factor again when you do m periods compounding with m periods compounding. So, let me write down discounting factors. So, when you write down m period compounding, what you have is the following, that then your this thing becomes 1 by so this is the amount of money I should pay, that this into A is the amount of money I should pay to get back A amount. If so, this into A, so which means what fraction of money I have to pay now, what fraction of A I have to pay now, so that I recover A at the end of time t. So, that is of course writing. So, this is the yearly discounting, and then this is the continuous discounting. And that is of course at any time t is given as e to the power minus st t. Now, of course, now once you know these, given a cash flow, suppose you are given a cash flow, so this is the amount of money that would your investment would generate. So, suppose you have the cash flow x0, x1, x2, x3, xn, and you know the spot rates. You know the spot rates. Okay. Once you know the spot rate, what is the present value of this cash stream? So, how much I have to invest now in order to get that cash flow in these time periods. So, the present value of the stream is so this is called the present value of the stream. So, you already know how to compute present value of cash flows, which we have studied earlier. But of course, you can say that how do you determine your spot rates? We said that okay, just look at the behavior of what sort of interest or what sort of yield a zero coupon bond is giving and say, okay, that is in 1 year, and then okay, that's take it as a, you know, your spot rate. So how to determine spot rate? How to determine spot rate? That's a key question. So to determine spot rate, notice the yield values determined from for yield values determined from the yield values of zero coupon bonds. Now, let me come to the idea that, let me tell you the idea that zero coupon bonds are very rare. It is not that in the market you have huge number of zero coupon bonds, so you see there some sort of an aggregate behavior and then try to determine something. Zero coupon bonds are rare, and as a result of which you do not have a reliable zero coupon bond unless you take government treasury bonds on which the yields would be very less. Now suppose you have a coupon paying bond, so and which say pays a yearly coupon of C. So can I determine spot rates from even if I have a coupon paying bond? So the question is, can I determine spot rates from coupon paying bonds? So I am going to give a very simple situation. I am talking about a very simple situation. So what is that situation? See, the idea is this: suppose I am looking at only yearly yearly spot rates. Suppose S1 is known. So if you invest for 1 year your money, then S1 is suppose known to you. But you know, let us consider a bond which pays a coupon C, coupon value yearly. So it pays you this amount of money yearly, not at certain given intervals that we had learned in the previous lecture, but here we are doing things slightly in a different way. So once that is known, it is clearly important to do the following. How would I now find S2? What is it? What is S2? Now how much is the price that I should now pay if I want the bond, the coupon paying bond at the end of 2 years should pay me a face value F. So the price which I pay should be this. So it should be the first coupon payment discounted by 1 plus S1. And in the second year, where I am at the end, where I have to pay both this coupon plus get the coupon as the face value of the bond. So if I know how much I am paying, if I know the coupon value and what I should get at the end, and if I know S1, S2 is known. So that is one way of finding spot rates. So now once S2 is known, you can go for other ones. This idea of short rates brings us into a very nice idea of forward rates. Forward rates are interest rates that you speak about not from a time 0 to a time t, but between two intermediate time values t1 and t2. And how is it that, how How do you compute that? What are the issues? We shall now discuss. So now we are going to study what we said is forward rates, and we'll explain why are we calling it forward rates. So forward rates are interest rates that are agreed upon by two parties at this time for a future time interval T1 and T2. So at time say t equal to say 0, I agree for interest rate that should be held during this time period T1 and T2, and I agree on an interest rate f. So any money that you accumulate at T1 and then the interest rate that would be levied on that capital between the time T1 and T2 will be f. So that this is what is called the forward rate. Forward rate. I am just writing a short form of forward. The SMS generation short forms are much more, or WhatsApp generation short forms are much more relevant, I guess. Now, what does it mean? What am I supposed to do? What is the forward rate? Suppose at time t equal to 0, I am looking at a scenario like this. Now suppose I want to invest at time t equal to 0, say 1 rupees 1 at time t equal to 0, I give it to the bank and I want to hold it for 2 years, then my spot interest rate is, or spot rate is S2. Okay. Now at the end of 2 years, the money that I will get is 1 plus S2 whole square, which we have already seen. Now instead of doing that, we do something else. That okay, now we might do something very funny. We might be more of a business type, and we said okay, let me do something. T is equal to 0, T equal to 1, T equal to 2. So I have 1 rupee which I have invested now in the bank, and with a spot interest rate 1, I said I will just hold it for 1 year, I will not bother about 2 years. So at time t equal to 1, I have 1 plus S money given to me by the S1 given to me by the bank. And I said okay, but I actually want to use this money over a period of 2 years, this 1 rupee. It could be 1 lakh of rupees, that's a different issue, but just 1 is a unit. So 1 plus S1, I will now loan it to someone, right? I loan it to someone. And I agree that at the time t equal to 0, I agree with someone that I will loan you this amount of money at a interest rate f. So at the end of period 2 years, so I have given somebody money 1 plus S1. Basically somebody has asked me for a money 1 plus S1 at time t. I said okay, what I will do is that I will place this rupee 1 at time t equal to 0 at spot rate S1, get this money, and I agree that I will give you this money between time t1 and t2. That time t equal to 1, I will give you that money. At time t equal to 2, t2, you give me back the money with the interest rate, but that interest rate is the forward rate that we decide upon. So at time t equal to t2, the money that you will get is 1 plus S1 into 1 plus F. But the question is, how would you know how to determine the forward rate? How would you know how to determine the forward rate f? How would you say to somebody, okay, this is my interest rate? You cannot arbitrarily make a statement like that. There are reasons for which you shouldn't make. To determine the f, so how to compute the f? We invoke what is called the comparison principle in the financial market. See, it says that the forward rate should be such a rate that the money that you generate by using the forward rate between T1 and T2 should be same as the amount that you would have generated if you have put the money in the bank for 1 year at a spot rate 2 and held it for 2 years. Bank or bond, whatever, zero coupon bonds. So the comparison principle then says that 1 plus S1 is equal into 1 plus F then must equal 1 plus S2 square. So then that will tell me that 1 plus F is equal to 1 plus S2 square by 1 plus S1. So that simply tells me that F is equal to 1 plus S2 square by 1 plus S1 minus 1. So here I have computed the spot rates or a forward rate once I know the two spot rates. Now, why this comparison principle was invoked? What was the use of this comparison principle? This comparison principle was invoked to stop what is called the arbitrage in the market. So market should be free of arbitrage. The comparison principle tells us that if you evaluate F in this way, there will be no arbitrage in the market. Market should be free of arbitrage. I will tell you what arbitrage is. We will use this concept in much detail later on. In a financial market, largely, the goal is that those who invest get paid. They may lose money also. The main goal of the financial market is to stop people from getting money or making positive amount of money without making any investment. So arbitrage is the art of making positive income without making any investment. So what would happen if the comparison principle is not invoked? Suppose I have, for example, that this is not equal but strictly bigger. So whatever forward I can, if I choose a forward rate F such that this is bigger than this, so I will have this, right? So if I am allowed to quote such a forward rate and not this forward rate such that this is strictly bigger, then I will show you, we will argue that we can actually make money without doing any sort of investment. How is that possible? Okay, let us argue on for this particular case. What I do is the following: I borrow 1 rupee from a bank, borrow for 2 years at spot rate S2. So at spot rate S2, right? Meanwhile, I take that 1 rupee and invest in the same way, invest in some other bank up to 1 year and then give it as a loan to somebody else, 1 plus S1 as a loan to somebody else. So at the end of 2 years, I have to give back to the original bank from which I took rupees 1 plus S2 square amount of money. But then because of this difference between these two is positive, I'll have, and this is what I will get. So from 1 plus S1, 1 plus F, which I get at the end of 2 years by investing that 1 rupee that I have taken as a loan, I have to give out the loan amount, and this difference is 0. So even after I give out the loan amount, I have positive money left with me, which means that I had no money with me. I came to a bank, asked for 1 rupee, they gave it to me at a spot rate of 2. I took that 1 rupee, invested in this way, got this money by quoting a forward rate such that this is bigger, and hence I get. So people will see, oh, everybody can do that and have fun, have lots of money. The answer is that when people try to do that, the market tries to balance themselves such that the only allowed forward quote would be this one. So of course you can argue it in the opposite way. You can completely argue it in the opposite way, and that I leave to you, or what argument you will make if it is strictly less than 0. So unless you have this equal, arbitrage will always remain, and this arbitrage operation is gradually observed in the market, and the market will only accept forward rates, will only allow forward rate quotes, which will be provided by this formula. So here today we have also introduced to you a very important notion of arbitrage, and how interest rate notions are linked with this very fundamental notion of arbitrage, the most fundamental notion of a market and a model of a financial market. So with this I close today's talk, and tomorrow we are going to start discussing optimization models in finance, and then we would talk about Kuhn-Tucker conditions and portfolio optimization and capital asset pricing model. So from the next class we will essentially be looking into the role of optimization in finance, and then of course this optimization is not free of stochastics. In some sense it's stochastic optimization, but okay, we can still handle things in a much different way. We can make it look as if it is generally the non-stochastic optimization. So we are going to talk about the use of optimization in finance, and we are going to talk about the capital asset pricing model, which is one of the most central concepts of whole financial theory. The man as great as Fisher Black has spent all his life thinking about the capital asset pricing model. Thank you very much.